welcome to the 5th Future of Electrification virtual conference. I'm Claes Avarsjö, Executive Director of SAPI Group. For those of you who don't know SAPI Group, we are a global provider of integrated solutions for electrification in industrial machinery, including motion power, charging solutions, autonomous navigation, telematics, and safety systems. We created the Future of Electrification conference to bring together OEMs, suppliers, end users, partners, and operators to move the conversation from hype to real-world implementation of vehicle electrification, sharing what is working, what is not, and practical lessons that will help accelerate electrification across industries. This session is being recorded and will be available to watch on demand after the conference. If you have questions during the session, please add them to the Q&A tab on the right side of your screen. Okay, with that, I'm pleased to introduce our keynote speaker. Dr. Michelle Dickinson, she is a nanotechnologist, entrepreneur, and Chief Strategy Officer at Worker, where she leads commercialization of AI-powered industrial robots for manufacturers. With 2 decades of experience spanning university research, global tech companies, and building business at the edge of emerging technology, she is known for making complex technology accessible without oversimplifying. Michelle's work sits at the intersection of deep technical expertise and human-centered thinking, with a focus on converging technologies which are reshaping industries. This is a very apt discussion for these times. So without no further ado, we are excited to have Michelle here today. Welcome, and over to you.
Thank you so much for that introduction, and a good morning or good afternoon from wherever you are in the world watching, or if you're watching later. Look, we're talking today about driving transformation, especially around electrification, and I have a personal interest in how AI is going to help us to advance in this field. And when we talk about driving transformation, it's usually driven by some leading factor. And it's really hard right now in the world that we're in to not be watching the price of diesel, for example, and see it doing things that, I don't know about you, but my 3-year plan did not anticipate. So while the price of diesel might help to sway some of the naysayers when it comes to electrification, I think the question is actually whether or not that's enough for the seismic shift that I think many industries know that they need. So we're here to do a bit of a chat today, but I want to preface that I'm not here to tell any of you what to do. I know that many of you have probably sat through several AI keynote talks and maybe some electrification keynotes over the last few years. And if you've sat through any of the ones that I've sat through, a lot of them were maybe more hype than actually practical advice that is useful. And so what I hope to do today is give you some reality. I am not a futurist. I call myself a nowist. I live in the now, but I do deal with a lot of future technologies. And so I want to chat about what I think the gap is between demos and deployments, the hype and the reality, and things that I think might actually help us to close this gap. So we're going to start, I guess, talking a little bit about why am I the person here talking about this. So a little bit of my background. And it's funny because if 30 years ago you'd have said to me, hey, Michelle, you're going to be here talking about AI in this keynote, I would have laughed at you because school for me it felt like a real disaster. My grades didn't add up. I wasn't good at writing essays. I fumbled on my tests and I watched other students around me be able to memorize facts that I couldn't find context for. And look, my brain just simply, it wasn't designed to do that sort of assessment. And so I made my way through school. I fumbled my way through school, believing that I wasn't smart because that was the reflection of what my grades told me. But outside of school, life was interesting. So when I was 8, my dad, who had dropped out of school when he was a teenager, decided to go back to night school to study for a diploma in electrical engineering. And when he laid out all of these wires on our dining table to study at night, and I said, "What is this? What are you doing?" He handed me a life-changing tool. He handed me a soldering iron and he taught me to solder. And my life has never been it's never been the same since. Because his gifting me a soldering iron and the gift of understanding how things worked meant that I spent my childhood fixing things. And I fixed things because I was interested, but I also fixed things because they were broke. And as a family, we couldn't afford to replace things. So I learned very quickly, if you wanted something to stay in your household, you had to learn how it worked and how to fix it. What I didn't realize at the time, because I wasn't getting an assessment or a grade for fixing things on the dining table, is actually my brain is designed to figure out how to take things apart and how to make them work better. And by the time I was a teenager, I was fixing things for coworkers at my minimum wage jobs. Somebody would bring in a toaster for me that had stopped working, and I'd take it home, fix it, bring it back to them. And it didn't feel like a skill at the time. It didn't feel like a thing you could get grades for. It felt like a hobby that I used to help people. And it's taken me a long time to realize that my hobby is actually a reflection around how my brain works, and that for many of us, our brains work differently. And for many of us, academics might not necessarily be how our brains work. But my brain works by naturally seeing how systems fit together. I am good at finding practical pass-through problems, and I'm good at building and fixing stuff. So there's a complicated story in the middle, but I ended up becoming an engineer. And for the last 2 decades, I have worked at this intersection, this wonderful place where hardware meets software meets the real world. And so, as was provided in my introduction, today I'm the Chief Strategic Officer at Worker, and we deploy physical AI robots, that's smart robots on real factory floors, which means that I get to spend most of my time watching very expensive hardware and very complicated software meet very messy realities. That is the reality of manufacturing. And I want to tell you this for a couple of reasons. First, maybe you empathize, maybe you understand this feeling. A lot of you on this call are engineers, you're builders, you're the people who can stand on a job site and actually see what's happening. And you can see what's happening in real time, not just what the spec said would happen. And maybe school didn't reward that skill in you either. And I want to talk about future skills. And I think the future skills that are coming over the next decade are these skills, our engineering skills. And I think they're going to reward us more than any decade in history. And I'm going to come back to that at the end. Secondly, I'm not here to sell you anything. I'm just here to report what I'm seeing as somebody who is deeply entrenched in the world of AI and hope that it might be able to help you. So you're going to learn, because I'm going to do this a lot in this talk, that I like to break things down into 3 things. I think 3 things is a really simple way of breaking stuff down. So you're going to see a lot from this today. But the 3 things that I hope that you're going to leave with today are these. Number 1 is clarity. I want to really separate AI. And look, I'm not here to teach you about ChatGPT. That's not what we're doing. I want to talk about how I think AI is actually going to help electrification and what it might actually do eventually, but what we can do today. So that's height from reality. Secondly, I really want to provide you with a framework to help you decide which, if any, AI experiments that you might want to run over the next 90 days at your organization and how to do that. And third, I want to touch on the AI I think we should be thinking about right now. And I want to give you an example of what I think is a really important signal for what product roadmaps actually really, I think, need to account for over the next 24 months and what I think those signals are that are shaping that. So back to my 3 things, my lucky 3. People talk about AI and electrification as if it's one thing. You know, you've got electrification, then you just plop AI on. But I actually think it's three separate things arriving on three separate timelines. And I think if you don't think of it as these three things and you pile it all in as one, it's why pilots in industry don't work or they stall. I would say I see it like a three different trains leaving the station at different times. Okay, one train's already moving, one train is boarding, and one train is pulling in, and you're deciding whether or not you want to get on it. So if we think about the three waves that are happening around AI and electrification, there's the one that's happening now. I call that wave one. That's AI inside the machine. So, that stuff that you would have seen, battery management, motor control, thermal optimization, a lot of those are integrated in a product right now. They're happening now. They're shipping now. Easy. And then we look at wave two, and that's AI around the machine. So things like fleet orchestration, duty cycle learning, digital twins, charging, scheduling. Some of you may already have those in your product, and that's great. But I think really it's going to be another 24 months before we consider this wave to be common practice and standard in most of our products. And then wave three, which isn't that far away, I'm sort of thinking probably around 36 months if I look at the speed that things are moving. That's AI as the machine. So that's autonomous agents maybe making the decisions that humans used to make. And I think if we look at how fast agentic AI is moving in the ChatGPT world, for example, I think this is going to be ready for serious real-world deployment much faster than we probably predicted. And the reason why that matters is because the architectural choices that you're going to make today and over the next 12 months are going to decide whether or not your organization is ready for this signal, which is agentic AI and autonomous agents. And so I think thinking now prepares you for what your next architecture probably should look like, and it's worth having that conversation. So 3 waves. We're probably all around wave 1. Maybe we're dabbling in wave 2 right now, and hopefully we're thinking about wave 3. I want to dig a little bit deeper into each of those waves for a second. So let's not stress. Let's talk about what's happening right now. Wave 1, it's AI inside the machine. And so I want to give an example that's within the ecosystem. So many of you may know Flash Battery. They're an Italian battery manufacturer, and they make lithium batteries for industrial vehicles. And for more than 10 years now, every battery that they've shipped has been part of a machine learning system, and they call that the Flash Data Center. So they have so much data, over 200 million logs collected from batteries operating all over the world. And they're bringing in 150,000 new logs every day. And so with that data, they're able to use AI to generate what they call a digital twin of every battery. So that's basically a virtual replica that can simulate behavior of that specific battery in that specific application, which means that you can do things like fault detection, and that can be predicted before the fault actually happens. So this isn't hype, this is infrastructure, this is being delivered right now. So if I think about wave 1 in this context, wave 1 is about understanding the battery state of health estimation in such a way that you can apply almost individual warranties to your battery packs. There's motor control that can retune real duty profiles to your real application rather than just the lab assumptions that were applied to it. That's things like thermal management that learns the machine's actual operating envelope, not just the spec at the beginning. It's things like vision-based quality control on the assembly line that allows predictive failure detection on the drivetrain. And like I said, those are shipping today. They're either shipping from you, or if you're not shipping that sort of tech in your current product, AI inside the machine, then it's probably being shipped by someone competing with you. So I would say if you're not running wave 1 AI yet, it's probably the standard that you need to just catch up to just compete at the space that we're at now. And it's good reflection on where your technology is and where we should be standardizing. So that's it now. Wave 2, and some of you are in wave 2, that's AI around the machine. So wave 2 is where I think over the next 24 months, competitive differentiation is going to live. And I really love this study that I want to share with you. It was published in 2025, last year. And it's where a Swedish logistics technology company called Einride, they published this beautiful study where they took real operational data from one of Germany's largest grocery retailers. And in that data, there were over 38,000 shipments, over 200 vehicles, 500 delivery sites across the Berlin region. And they just ran a really simple experiment. And the reason why I like this study is it's just so simple. It's comparing one against the other. So they compared two strategies for electrifying that busy fleet. So strategy one was just straight swap the diesel trucks for electric ones and keep everything else the same. So, I mean, that's the power of electrification, right? That's what we're talking about in this conference. But strategy two was to swap the diesel trucks for electric ones, but also use AI to replan the entire fleet from scratch. So that's replan routes, that's replan charging schedules, that's replan assignments. And if you sort of look at the data I have on the screen, you can see that basically if you do a straight swap, so that's the blue graph, sure, electric truck handled 57% of the payload, 30% of the mileage, which is about what you'd expect and sort of what most fleet operators are achieving today. But if you look under the AI replanned approach, so that's AI plus electrification, the electric trucks handled 85% of the payload and 54% of the mileage. And importantly, because we all care about money, the total cost of ownership numbers were really important here. So in the straight swap, we were at 3% savings versus all diesel, and this was mostly dependent on subsidies. But in our AI replanned approach, we were up to 13% total cost of ownership reduction, and that was without subsidies. So the AI planned fleet was cost comparable, if not better than diesel. And so if we think about this story and electrification, what the story says is that electrification on its own financially barely beats diesel. And we sort of know that. I mean, it's a feel good, but, you know, it doesn't affect some of the other things. But electrification plus AI, I mean, the data is really clear, and this is just one of many studies, it decisively beats diesel. And, you know, we've got this quote from one of the authors in the study that basically says that planning software that integrates route and charging planning at the fleet level has a significantly greater impact than just increasing the battery size or the uncoordinated expansion of charging infrastructure, which basically means that software beats hardware. It also means that bigger batteries are not the answer, and the charging network on its own isn't the answer. The answer, if we want a superpower electrification, is actually the intelligence layer that decides moment by moment which machine is going where and when. And that is wave 2 in a nutshell. And it's already here for some of you. And this peer-reviewed study is great if you want to have a read about it. But this is where we're getting what I call smarter, not just cleaner. So when people talk about electrification, we're often thinking about being smarter or being cleaner, but being smarter is also more important, I think, because the winning argument for electric is that a diesel machine can't get smarter after it leaves the factory floor, but an electric one can. And so, you know, for every month that your electric loader is in the field, for example, I think it should be a better loader than the month before. And AI is what makes that sentence true. And I think it's the only story that competes with diesel on the economics and what the operator actually cares about, which is productivity, uptime, and total cost of ownership. So I think the real story when we talk about electrification and AI is not just cleaner, but also smarter. So how do we do this? We have to think about, you know, internally, we've got this value chain in our matrix, and every company function has a role in every wave, and you're going to sit in one of these waves. So I sit in engineering, but you may sit in manufacturing or operations. And as we go through these waves, I think it's worth thinking about where you sit and what your role might be. And these are all cross-functional roles. So engineering might run digital twin simulation right now in wave 1. They might design for over-the-air updates in wave 2, and maybe they're architecting autonomous modes in wave 3. Whereas manufacturing might be running vision-based quality control right now, maybe adaptive robotic assemblies in wave 2, but maybe fully autonomous cobot lines in wave 3. In operations, you might be running duty cycle learning right now. Maybe you're thinking or implementing fleet orchestration in wave 2, and then maybe we're looking at semi-autonomous operation in wave 3. Now, if you're into maintenance, we're probably running predictive failure detection right now if you're in wave 1. Hopefully remote diagnostics in wave 2. But, I look forward to this future of self-scheduling machines in wave 3. And then we think about, product performance and BMS optimization right now as a priority, but really continuous over-the-air improvement in wave 2. And my dream, and I don't think we're far off that in wave 3, is machines that adapt to our customer sites. So my suggestion is, and you can screenshot this if you like, if you walk away from my talk today and you put this matrix up on a wall in your office, this might just help you with your 24-month strategy. So every cell is a potential experiment that you could be playing with. Every column is a capability that your company is either building or maybe watching somebody else build. But if you're not sure where to start, this could be a good matrix to not only figure out where you fit, what you should be thinking about, but also where your colleagues should be thinking and how do you work together in that thinking too. Now, it's all great to talk about AI and electrification, and we're going to do this, and this is our roadmap, and here's my matrix over the next 24 months. But as a person who is involved in real world deployments, many of you know, if you deploy in the real world, the reality of the real world and the reality of what you're running either in simulation or in your lab is never the same. So I want to talk to you about an installation that we have done at Worker recently, and it's one that, it reminds me of how fun the real world is. So it's a beautiful installation. It's an AI-powered robotic arm, and it's designed to pick up big ceramic tiles and place them into a wet saw to be cut. It's designed in the lab here. It was tested in the lab. We won FAT tests, factory assessment tests, and we validated it against every scenario that we could model. And it worked perfectly in simulation. And it worked perfectly when we commissioned it in the real factory for about 2 days. And then something happened that I couldn't have predicted. And now I look at it, I go, oh yeah, that's obvious. But this is what happened. So above this robot arm, hanging from the ceiling, we have a camera. It's a photo neo camera. And it helps us to understand what's going on using our physical AI. And so I've circled our camera up here, hanging off the ceiling above our robot in this factory. And the thing we never predicted, and the thing that I laugh about now, is that it turns out if you mount an electronic device on a high beam in a warehouse that is open to the world, birds will see this as a heated perch. And I did not at all put in any of my models birds landing on this very warm, very lovely warm bird perch, aka our very expensive camera. And birds landing and then taking off from our perfectly calibrated camera that actually needs to be in the exact position for our robot to accurately pick up tiles. Let's just say that was not helpful. But no amount of CAD modeling, no amount of thermal simulation, no amount of customer interviews, I think, would ever have told us about the birds. I think the only way we could ever learn about the birds and then have to solve it with some bird spikes, it was to put the camera on the ceiling and to wait. And I tell you this story because I think, the single most important thing that I've learned around deployment and especially around AI and electrification is that the machines that you ship this year are going to teach you things that you just can't learn any other way. The lab is a great rehearsal, and it's a place where you can really knuckle down on what you think are all the external factors, but the site is where you're going to get your performance. And so I think, those companies that try and perfect everything in the lab, they're not going to be the ones that win in the next decade. I think the ones that actually ship fast enough and find their own bird's nest equivalent are actually the ones they're gonna win, because the cleanest lab data is not realistic of the real world. And every deployment I've ever worked on has had its bird moment. So I think the goal is not to avoid the birds. The goal is to find them fast, to find them before your competitor find them. Because, the bird story or whatever it is that happens in a messy reality deployment is actually where real product gets made, and real product gets made better. So I love the birds. I love the story. I'm constantly reminded that we can work in the lab as hard as we want, but actually fast deployment helps us to get there much, much faster. So we've talked a little bit about wave 3, and, I'm not going to go into the hype around what I think is coming in the future, but I want to be very practical around wave 3. So wave 3 is what I think is coming, and wave 3 is sort of AI as the machine. So I think it's marking a shift towards autonomous operations, and we're moving from concepts to concrete engineering roadmaps. And, this is a tractor that decides its own path, a tractor that optimizes its own seed placement, for example. This is a forklift that chooses when it needs to charge, which route to take, and which workload to prioritize for efficiencies. This is a bus that schedules its own maintenance, for example, and reports its own degradation 3 weeks before it fails. Wouldn't that be a dream? And many people think this is a years away, but like I said, I think it's on my 36-month roadmap. And there's some organizations who are introducing this concept to market now. So this is one of them. This is CNH's industrial R for autonomous robot, which they sort of took out to a trade show last year. And it's designed, number one, it's hybrid, fully electric, designed to handle repetitive tasks like inter-row mowing, tillage, spraying autonomously. And they're claiming it has 95% seed placement accuracy, plus or minus 5 centimeters. 60% herbicide savings because it's got targeted AI-driven spraying. Almost 8% throughput gain on combine automation. And so, all of these are positive things. And if I look at this as a product, we would have put a system integrator into this problem for 2 weeks to 2 months to configure a robot like this, or an autonomous tractor like this. And now I think we can run a demo like this in minutes. And so, I think if you talked to me a year ago, I'd have assumed that maybe this autonomous off-highway system was at least a decade away to have them running on their own. But I really think the curve has moved. I think it's accelerated. I think it's moving so fast in software, and software eats hardware roadmaps for breakfast. And so I think we need to be looking at some of the software signals that are happening that are going to help really shape our hardware roadmaps for the future. So, anybody who's been to an AI talk recently, you might have somebody talking to you about, ChatGPT, or maybe Claude, or, how you can build an agent. I'm not going to talk about that. I'm going to assume you have some sort of AI tech literacy. And if you don't, it's easy. Just go to ChatGPT and ask it to help you learn about that. I want to talk about something that I think is a big signal that happened this year, that if you haven't played with, or you're not playing with, it's definitely worth playing with to understand how fast this is moving. And so you may have heard about OpenClaw. It was only 4 months ago that an Austrian developer, Peter, he released this open source AI project called OpenClaw. And, it was massive, 140,000 stars on GitHub within 3 weeks. And, it was so big that OpenAI basically captured Peter and brought him into OpenAI. And this project has been handed into a foundation, and it's been adapted in China to work with DeepSeek. It's running across the world right now on many different platforms. I'm running it on a separate computer because I don't trust it from a privacy perspective, but it is fun to play with. And I'm not expecting any of you to deploy OpenClaw on a forklift right now. In fact, I don't think you should do that. But I do think you should play with it. And I do think we should think about paying attention to signals like this and what this means, not only from a software perspective and how it's moving, but also what our customers are actually going to expect from us very, very shortly. So if you haven't used OpenClaw, it's not a chatbot in the traditional AI function like you might use ChatGPT. It's not a classifier. I call it an AI that takes action. So in my case, I use it to read my emails for me in the morning and then summarize them, help me prioritize them. And if I want, reply for me. It schedules things on my calendar on my behalf. It joins platforms on my behalf. It basically decides what to do, and then it does it. Now, it's not all good. It doesn't do all good things. And for me, it's crossed the line many, many times. And I think that matters because I think once we start applying this sort of technology to hardware, that same line is going to be crossed by the machines that you ship. And we have to think about how we put some guardrails around this. So I don't want a forklift out there that doesn't wait for instructions. Well, I do. I want it to decide the next job. I want it to route itself. I want it to schedule its own charging, but I want to have some boundaries around when it does that and how it does that. So in my dream world, an OpenClaw running a forklift is amazing if I can trust the system. I just don't think we can trust it yet. But, let's think about this. The architecture of an AI agent that is orchestrating your charging, your routing, your duty cycle optimization, setting up your maintenance scheduling. It's actually the same architecture that OpenClaw is talking about. It's different hardware, but it's the same software problem. And I think if our industry figures out the answers first, I think that's going to be the industry that wins. So the industry that's able to have an AI that takes action safely around our hardware, I think that's a very small step away now if we look at how fast the technology is moving. And I think that's going to have a significant impact on what's happening. But OpenClaw is not all rosy. I want to talk about things that we really need to think about. So I'm going to talk about a fun one first. On the left-hand side, you'll see this cute little love pot. And I don't know if any of you followed this story, but if you're designing autonomous systems, I think the story is interesting and important and makes you think of context. So a few months ago, a student who was a computer science student called Jack Leroux, he downloaded OpenClaw to try it out, like many of us have, and he connected it to a chat model like many of us have. He connected to his WhatsApp, and he told it a little bit about himself, including that he was looking for love. Reasonable, just a little bit of a bio, and then he went to sleep. Now, he woke up the next morning and his AI agent had automatically signed him up for a dating site, which is called MaltMatch, which is a platform where AI agents basically flirt with other AI agents on behalf of humans. It's a weird world, but it exists. And his OpenClaw had written him a profile, and it described him as the kind of person who'll build you a custom AI tool because you mentioned a problem. But here's what I think is interesting. Number one, Jack didn't ask his agent to do any of that. The agent just read his goal to find love and inferred about a way that he would achieve, or it would achieve it, and it just went and did it. And that sounds good, right? Agents just doing what I asked them to do, solving my problem. But the other part of the story is the part that I think is a bit more concerning. So on MaltMatch, this agent dating area, the most popular profile on there is a woman, and her name is Jane Wu. She's the third most wanted profile on the whole platform, and journalists interested in who she was tracked her down, and they found out that she actually is a freelance model in Malaysia, and her real name is June Chong. And what was interesting is her modeling photo, she was a model, had been uploaded, and she didn't have an AI agent. She'd never used the dating site. She'd never even heard of MaltMatch or OpenClaw until a reporter called her. What had happened is somebody had scraped her photos off the internet, fed them into an AI agent, and that agent was now out there in the world, matching with her, flirting as her, representing her. And, she was interviewed where she said, I feel very vulnerable. I didn't give consent to this. And that word consent, I think, is so important when we're talking about agentic AI. And I think the lesson here is not that AI is scary. AI can be amazing, but that I think the word consent is something that every engineer now is going to have to think about when we design autonomous systems, and who consents and what should be consented for. And it goes back to our guardrails, because when we think about our next product cycles, we're going to be designing agents that will act on behalf of somebody in the system. And so the moment that agent acts, I think we have to ask the question around whether it acted with genuine consent, proper authority within its brief. And I think, that's not just a moral question in our industry, that's a legal question. And it goes back to how do we make sure we've got good guardrails around this? And I don't think we're having that conversation yet, not around industrial electrification, because we're still playing with OpenClaw and we're still learning all of these fun things it can do. But I do think it's a conversation that will happen, and probably one we need to be thinking about. And the second side to this OpenClaw story, and anybody who's used OpenClaw knows that there's this skills marketplace, which is sort of where third-party developers write these plugins that add capabilities to your agent. So I use ones to help me read my email, book flights, read my calendars, control browsers, for example. So I pick those skills in that marketplace based on what I want my agent to do. It's very convenient for me. But also there's a study by Cisco that shows that it's also very dangerous. So in January this year, Cisco's AI security research team decided that they were going to test one of the most popular skills in the marketplace. And it was called, and I'm not making this up, it was called, "What Would Elon Do?" And it had actually been gamed to rank as the #1 skill in the entire repository. Tens of thousands of users had downloaded it. And so Cisco ran their scanner against it and found 9 security findings. 2 are critical, 5 were high severity. And basically this skill that everybody was downloading was malware. And buried inside it was a silent curl command, just a single line of shellcode that sent the user's data to an external server controlled by the person who wrote the skill. It didn't have a pop-up, it didn't have a warning, there was no indication that the user screen popped up that anything had happened. And the skill also had this prompt injection that instructed the AI to bypass its own safety guidelines and to execute that command without asking. So I think the #1 most popular skill downloaded by tens of thousands of trusting users was quietly pulling all their data. And that's not a bug, right? That's somebody gaming a distribution channel the same way that App Store malware has been gaming app stores for decades. But this time the software isn't being distributed as a game or a tool. It's an agent with full access to your email, your calendar, your files, your life, your equipment. So, fine, if it gets into my email or my calendar, okay. But what if we substitute email and calendar to our lives, where we think about fleet telemetry or charging infrastructure or over-the-air firmware pipeline? I think it's the same architectural problem, but instead it's on a platform that maybe weighs 8 tons and operates next to humans. And now this gets serious. So neither of these stories are a bug, the "what would Elon do," the love bug, whatever. They're just features. They're doing exactly what they were designed to do in the conditions that the designers did not anticipate. And I think this is maybe a bird in a factory moment on a global scale. And I think it's why we need to think about agentic AI and especially cybersecurity as a category within itself. So OpenClaw and the trends that it produces are going to mean that cybersecurity risks are greater than ever before. And if we think about what's actually happening on our machines in the next product cycle, we've got connected batteries reporting telemetry to the cloud, over-the-air firmware updates, rewriting motor control logic after the machine has left our factory. We've got autonomous decision-making running on edge compute, for example. Third-party software in our supply chain, every one of these, I think, is now an attack surface. And And the threat model for an industrial machine, I think, is different than a threat model for a laptop, right? If I download this and my laptop is compromised, well, I've lost some data maybe and I need to buy a new laptop. But a compromised 40-ton loader on a construction site, it's got some serious consequences. Having said that, and I think cybersecurity should be probably the top thing we're thinking about this year, there's opportunity hiding in this problem. The companies that are going to get ahead now are going to have a moat that their competitors, I don't think, will be able to cross if they get there fast enough. Because once regulators actually catch up and get serious about industrial cybersecurity, which they will, and I think it's not really going to happen till a high-profile incident happens, but it will. I think the cost of retrofitting security into a platform will be measured in product cycles. And so building it from the start, I think, is the only version that actually is going to work and is going to work well. And so this really is a wave 2 problem arriving on a wave 1 timeline, right? And I think it's one of the cleanest competitive advantages available to the companies here in this room. So my suggestion is don't wait for regulation. If you haven't started playing with OpenClaw or agentic AI, definitely do it in an isolated playroom, sandbox it, don't put it on your hardware yet, but understand the signals that it's providing, and understand where things I think are going to move very quickly. So here we are. We want to apply some innovation. Maybe AI is part of that. Innovation is really hard inside a company that ships things. And if you're an engineer, you've probably had the same experience that I've had working in larger corporations, which is you pitch this great idea internally. Somebody asks you for a business case, you build one. Somebody asks you to size the market, you do that, you try, but your 2-week experiment turns into this massive 6-month planning exercise where you need sign-off from so many people, and somewhere around month 4, it dies in a committee room and you sort of lose all of that inspiration. And look, this is not you and your colleagues being bad at innovation. This is just an institutional machinery problem, because the framework that made your company good at shipping reliable, validated machines, the frameworks that mean your products don't fail on a construction site, those are the same frameworks that make it really hard to run a 90-day AI pilot experiment where the cost of being wrong is measured in weeks. So these are the same frameworks. You can't have one without the other. The company that ships 0 broken loaders also ships experiments slowly. That's sort of just how the system works. And so the question is not how do you become more like a startup? Startups fail 90% of the time. It's a terrible hit rate for a company who is running equipment next to humans. The question is, how do we give ourselves permission to run small, fast, cheap experiments that on the 5% of our work where speed matters more than validation? And that's why I think it's most valuable organization capability that your company can build over the next 24 months. So back to I love 3 things. So here's the framework that I love for internal innovation. And that's really simple. Ask yourself, what specific problem does this solve? So does it solve a specific electrification problem? And this has to be really specific. So this is not the question, does it need AI? Do we need AI in our fleet? That's not a problem. That's a buzzword. The problem sounds like, our charging window is killing second shift utilization by 22%, or our warranty claims on pack degradation in cold climates are eating our margin. It's specific, it's measurable, and it's owned by somebody. Question number 2 is, what would have to be true for this to work? And I think this question does the heavy lifting, and the answer is never in one department. So this is where you actually have to find people to work with. So we need to understand operator behavior, and that lives with operations. We have to understand sensor coverage, and that lives with engineering. We have to understand data access, and that lives with IT. So you cannot answer this question alone. And the magic of question 2 is it's going to force you to get the right 5 or 6 people in the room for 45 minutes to brainstorm before you even spend any money. And that 45 minutes might actually save you 6 months. Question number 3 is, how do we learn fast without betting everything? So to do that, I have a model, and it's really simple, and it's one machine, one duty cycle, one metric, one quarter. Very simple. I'll go into that in a second. So if you cannot express your experiment in that form, you're not really running an experiment, you're running a program. So, if those 3 questions sound simple, they're supposed to be. There's the 3 things. The framework is not the hard part. The hard part is having the discipline to stop any idea that doesn't answer all 3, and to stop protecting the ideas just because they have political momentum in your company. So if you want a 90-day template for an experiment, for example, it's really easy. You just pick one machine from your existing product line, not a new platform, but something that's in the field today, something your customers already use. Pick one duty cycle where you've always suspected that there's an efficiency that you can't reach with deterministic control. Maybe it's cold weather degradation. Maybe it's the last 20% of battery capability on long shifts. Maybe it's a specific site configuration where your motors run hotter than the spec that they said. Then pick one metric that you can measure at the start and measure at the end. Energy consumed per cycle, pack temperature variance, operator override frequency, time to full charge, just one number. And then pick one quarter, 90 days, not 12 months, not 6 months. If you cannot get a signal in 90 days, your experiment is probably designed wrong. And then you've got to find your 5 or 6 people who need an answer to question 2, what would have to be true? So that's one engineer, one data person, one from operations, one from product, one from the customer facing side of your business. You're going to need these 5. Any fewer, and you're going to ship something beautiful that nobody uses. And at the end of your 90 days, you're going to have 1 or 3 answers. 1, it worked. Great, scale it. 2, didn't work. For now reasons that you understand, in which case you now know where to look next or where not to move forwards. And 3, it didn't work for a reason that you don't understand, which, is sort of like, in my case, you found the bird in your factory. And actually that is really important data for learning. So all 3 are valuable. And they're better than not running any experiment at all. And they work really well when you have a small cross-functional team. So that's 5 people given permission to be wrong, given a budget, given a deadline, given the authority to kill a project if the question doesn't have a good answer. Now, when it comes to finding your 5 people and thinking about your value proposition, I always say with your 5 people, start looking at people in work right now. The 5 people that you want are not the 5 people who sound the smartest, but the 5 people who are constantly asking questions, the 5 people who always have curiosity in their mindset. And once you start looking for people who ask questions, you can't not see it. And that is a really good driver of the type of people you want in here. You don't want people who already think they know the answer. You want people who are asking good questions. And then just do it. Pick your one and then run it. And I'd love to hear 90 days from now what you ran and what you learned from it. It's a really simple framework. It's something that I use to pilot a lot of things. And I think if you're really clear to those metrics, it works really well. So summing up, I spent a lot of years believing that school had already told me who I was. I then spent 2 decades discovering that it hadn't. And my brain is great. It's not academically great. I didn't get good grades at school, but my brain is great at seeing systems, finding practical paths, building things with my hands. And those are the skills that I think every AI deployment I've ever worked on actually depends on more than any other. I do not have a crystal ball, but this is what I believe will be true over the next decade. I think these skills are about to become the most valuable skills in the industrial world. And they're not the skills that AI is good at. They're actually the skills that AI is really bad at. AI is good at pattern matching across massive data sets. AI is really bad at walking into a factory and noticing that warm perch on a high beam that will attract birds. AI is really good at optimizing duty cycle given perfect data. It's really bad at knowing which data is actually trustworthy because it doesn't know the site. So thinking about our human skills and our engineering skills and the skills of us in the room, the people sitting here right now, Those are site intuition, those are judgment under ambiguity, those are customer empathy, those are cross-functional translation. It's knowing which data to trust, it's noticing when something doesn't belong, and it's deciding what's actually worth doing. Those are not going away, and I think they're becoming more valuable, not less. So I think the engineers are going to define the next decade of off-highway equipment are actually the engineers who learn to use AI as an amplifier of judgment, not a replacement for it. And I think, your experience, your site knowledge, your feel for the machine, your ability to stand in a warehouse and just know what's actually going to happen here, that's the asset. And AI is going to be your lever. So I think the future belongs to us. The demand signal around OpenClaw has shown that we need to think about agentic. We need to think about our machines doing things on their own, learning on site, predicting our maintenance. That's a product. It's not a concept. And I think the people who are going to build that are the people here in this room.